Welcome back. Now, we'd like to see some blood when we hit the enemy. Now we're getting into the realm of visual effects, or VFX for short. Now, Unreal Engine has two different systems for creating visual effects. It has Cascade and it has Niagara. Now, Cascade is the legacy system. It's what we had before Niagara came around. And it was a good way to create particle systems that looked really nice for our games. Now, Cascade still works, and we can still create Cascade particle systems. And because it's the legacy system, there still exist lots of resources for Cascade particles. Whether you're searching the Unreal Engine Marketplace or checking out some of the free content provided by Epic, there are lots of projects that contain Cascade particle systems, as well as assets on the marketplace that we can get for free or we can pay for. Now, we spawn Cascade particles using some of the functions in the uGameplay Statics function library. So it's gameplay statics that we use to spawn these Cascade particle emitters. Now, Niagara is the new system. It has an improved workflow. It's generally a little bit more user-friendly for artists to create visual effects, and you can create some really nice particle systems with Niagara. Now, Niagara has its own static function library, and it's called uNiagara Function Library. And we use this library to access functions for spawning Niagara systems. So you might be wondering which one is better. Well, Niagara is clearly better. It's the new and improved system. But as a game developer, you should know how to use both systems. Now, you don't necessarily need to know how to create particle systems in Cascade, or Niagara for that matter. But if you're going to learn how to create visual effects, of course you're going to want to learn the new Niagara system. But because so many particle system sources exist for Cascade, you should know how to at least spawn particle systems from both Cascade and Niagara. Now, the creation of visual effects is its own science. It's kind of like creating other art assets, such as meshes and environments and characters and animations. It's really its own skill that people have developed in order to create these beautiful particle effects systems for our games. So we're going to learn how to use both of these systems when spawning effects in our game. And we're going to start by spawning some blood particles when we hit the enemy. And if you know how to spawn effects of both systems, then you're more versatile and you have more options as you're searching for assets, say on the Epic Games Marketplace, for example. Now, I'll be providing you with a blood particle effect system, and this is a Cascade particle system, and we're going to learn first how we can spawn Cascade particles. So let's get those blood particles. Now, to get those blood particles, you're going to go to the GitHub page for this source. In the Downloads folder, we have Effects, and in the Effects folder, there's this blood.zip. You can simply click on it and then click Download to get this zip file. Now, this is a zip file, so we have to extract it. I'm going to show it in my Downloads folder. So here's my blood.zip. I can simply right-click and extract all, and go ahead and click Extract to get this blood.zip folder extracted, and it'll turn into blood rather than simply blood.zip. And inside of blood, I'll go ahead and double click it just to show you, we have this effects folder, inside of which we have other folders which contain all of the things this blood particle system needs to use. And we can simply get this into our project. Now, I'm going to show you a way to get this folder into our project still intact, so the particle system and all the references to the assets in this folder that it uses are all intact. To do that, I'm going to take my project folder and go into my content folder. And here in content, I can simply paste this effects folder. So I'm going to take my effects folder, Control-C to copy it, and right here in my Explorer view, in my content folder of my project, I'm going to hit Control-V and simply paste it in here. Now I can open my project. I'm simply going to double-click /.u project to open this. And now here in my project, I'll go ahead and click Cancel on that pop-up down at the bottom right and open my content drawer. And there's the effects folder. And in the effects folder, We have particle systems, we'll go into that, gameplay, player, and here's a cascade particle system. It's called B-Body Bullet Impact. And if you're curious where this came from, it came from an Unreal Engine example project provided by Epic Games called Shooter Game. And you can access that from the Epic Games launcher if you go into Samples. You can scroll all the way down until you find the Shooter project. And here it is down at the bottom. It's called Shooter Game. So much like the other example projects provided by Epic, this Shooter Game has a blood effect particle system. That's what we have here. Now we can double click on this to see what it looks like, and we're presented with the Cascade editor. And you can barely see it because it's dark, but we have a blood particle effect. I'm going to go ahead and close it. And this P-Body Bullet Impact can actually be dragged into the world. And we'll get this instance of the effect. And if I press play, then we'll see that particle effect. It's kind of hard to see because it's pretty short-lived. I'll move it up into an easy-to-see location and press play, and there it is. It looks like a blood splatter. So now that we have this effect, we want to play this particle effect when we hit the character. Now, I'd like for our enemy character to have a variable for this particle effect. That way, each individual enemy can have a different blood splatter if we wish to change it from enemy to enemy. Maybe we have some sort of insect creature and it bleeds blue, so we might want a blue blood splatter for the insect. So putting the particle system on the enemy itself is a good way to get that versatility. Now, I can right-click on this enemy here in the world and click Browse to Asset to open my BP enemy in the content drawer. And I can open it up, and right here, we're using Play Sound at Location just to test out the attenuation. We don't need this anymore, but I'm going to keep it here because I'd like to use this delay to spawn some particle effects as we're playing those sounds. So I'm going to right-click here, and the function to spawn a cascade particle system is called Spawn Emitter, and we have Spawn Emitter Attached and Spawn Emitter at Location. Spawn Emitter Attached will literally attach that emitter to a given component. So if it's not so short-lived like our blood splatter, but maybe fire, for example, that you might have on a torch, spawning it attached to a component will, well, keep it attached to that component, whereas spawning it at a location will simply spawn it at that location in the world. I'm going to choose Spawn Emitter at Location, and we're going to spawn an emitter. Now, Spawn Emitter at Location is a function. If we hover over it, we see that target is gameplay static. So it's one of the gameplay static functions. I'm going to do this right after we play the sound at location and hook that up to the delay. So every 1 second, not only are we playing a sound, but we'll also be spawning an emitter. Now, this function takes a number of input parameters, the first of which is called emitter template. And if we hover over it, we see that its type is particle system object reference. When we refer to a particle system, we're talking about the Cascade legacy system. Niagara uses Niagara systems, so there's a difference there. Now, we can select a particle system directly, and we have quite a few here because some of these particle systems came with some of our asset packs that we've imported into this project. Now, we can select the P-Body Bullet Impact particle system here. And because this is Spawn Emitter at Location, we need to specify a location. And we can specify the enemy's location by simply dragging in the result from our Get Actor Location node straight into Location. Now, the rest of these inputs we can leave as is. We don't need to change the rotation or the scale, and this Boolean called auto-destroy means that the particle system object we're creating or spawning will be destroyed as soon as that particle system is finished playing. So that's a really nice way for our memory to be automatically managed for us. Now, we don't need to worry about the pooling method. We could optionally choose a pooling method, auto-release or manual release, and this would allow us to specify the way that our particles are pooled. A pooling system is basically just a set of memory locations allocated for a given number of objects, like particle systems, so that each time a new system is spawned, it takes one of those memory locations, and when it's done, that memory location is freed. So there's always a limited number of memory locations used at any given point in time, which allows us to not take up an arbitrary number of memory locations by spawning too many particles. Now, Auto Activate System does what it says. As soon as we spawn the emitter, we'll activate it, which means we'll start to see that system get played in the world. So now that we're spawning an emitter at a location, let's go ahead and press play to see what this looks like. And we can simply walk up to one of these enemies and we can see that blood system. Now we're spawning it right there in the middle of the enemy. So it's kind of in the center of the mesh. So if we really wanted to see it in its entirety, we could move that location. Instead of the actor's location, I can hold Alt and click on this input to break that pin, and we can alter this location a bit. For example, we can push it out forward by the actor's forward vector, scaled by some value. So I can right-click and type Get Actor Forward Vector, and get the forward vector and multiply that by some value by hitting the asterisk, choosing multiply, and I can scale X, Y, and Z by, say, 100. And then we have our forward vector multiplied by 100, and if we add that to the actor location, well, thanks to vector addition, the result will be the location at the tip of that forward vector after placing its tail at the actor location. In other words, we're getting the actor location pushed out by 100 units. So we can get actor location, get an add node, and add the result of this vector scaling. And if we plug that into the location, now we'll see a blood splatter 100 units straight out in the forward vector direction of our enemy. So let's press play and run up to the enemy. And now we see that blood splatter in all its glory. And that's what it looks like, a simple blood splatter particle effect. That's what we want to spawn when we swing our sword and hit the enemy. That's our goal. So now that our goal is clear, let's go about actually doing this. We know that we can spawn an emitter using a blueprint node, but we're going to do this in C++. Now, playing this sound and spawning this emitter, this was all just done for demonstration purposes, so I can really just highlight these and delete them, or if you want to keep them there, you can hold Alt and break the output execution wire from begin play, and now these nodes will never be reached because there is no flow of execution reaching them. So either way is fine. I'm eventually going to remove those, but for now, I'll leave them there. So we know our goal, and we want our enemy to have a variable of this cascade particle system type. So this is going to bring us back into our Visual Studio project. I'm going to go ahead and open my /.solution file. And here's our project. I don't need all of these open right now. So I'm going to go to enemy.h and right-click on its tab and select Close All But This. And now I just have enemy.h open. Now I'm going to make some room here so I can see my code. And right here in the private section, I'd like to add a new variable for this particle system. So let's do it. Now the type for this particle system is going to be uParticleSystem. That is the type for a cascade particle system. And I'm going to call this hit particles. I could call it blood particles, but if later on down the road we make some other type of enemy and the hit particles are something else other than blood, for example, we might have some stone golem and we want our hit particles to be chunks of stone, then we don't have to rename it to stone particles. We can just call it hit particles and be done with it. Now, I do want to edit this in our blueprint, either the default or on an instance. So I'm going to copy this U property for hit sound and paste it here so we have edit anywhere. And instead of category sounds, I'm going to place it in a category called visual effects. That way it'll be easy to find this variable from blueprints. So now that we have a particle system, the question is, do we need to forward declare this type? You may have noticed that I didn't forward declare uSoundBase, and I didn't get a compilation error because some types are just built in. Well, we can find out if we want by hot reloading. Now, so far all we've been doing is hitting save and then hopping back into the editor. To hot reload, we've been pressing this hot reload icon to kick off live coding. But we also saw that there was a keyboard shortcut, and I'd like to try that from here. And that keyboard shortcut is Control-Alt F11. And by hitting that, I've kicked off live coding straight from my IDE. So we'll let live coding do its thing. And we see that live coding has completed successfully, which means we do not need to forward declare uParticle system. And back here in the editor, now that we've live coded, we can go back to BP enemy, select BP enemy self, and search for that category we created. Scrolling down, here it is, it's called Visual Effects. And there's our hit particles. And I can select the dropdown and choose B body bullet impact, and now I have that variable set. So now that we know a shortcut for kicking off live coding, we no longer need to hop back into the editor to live code, so that's great. So now we have a cascade particle system, and we know that in order to spawn this, we need to use gameplay statics. So I'm going to hold Control and press KO on the keyboard to open my enemy.cpp. And up at the top, I see that we already have gameplay statics included, as we're already using it. So that's great. Now we just need to spawn the emitter. Let's go down to our getHit function. Here it is. All we're doing so far is playing the hit sound at location. Now we want to spawn an emitter at location using our hit particles. Now, it's a good idea to check that pointer. So if hit particles, we'll make sure that's valid, and then we can get gameplay statics. So gameplay statics, and we're going to call spawn emitter at location. There it is, right there. Let's go ahead and use that. I'm going to open the parentheses, and we can see our inputs. I'll go ahead and hit return so I can have each argument on its own line. Now, notice that the first input is of type uWorld. We actually need the world here. Play sound at location was a little different. It needed a world context object. That's why we used this. But for the world itself, well, we need the world itself. So we can simply call getWorld. We can be pretty safe assuming that that world pointer isn't going to be null because we're here in enemy.cpp. This will be called from the enemy in the world, which means there's already a world in existence. So we're not going to have any problems simply calling getWorld and passing it straight in. If we want it to be extra safe, we can add an AND here in the if statement, calling getWorld here to see if that returns a null pointer before we even get to this line. But really, it's not that big of a deal if we leave it out. I'll leave it in just because I can. Now, Control-Shift-Space is going to pop up my useful little pop-up here. And the next input after world is emitter template, and it's of type uParticle system. Well, we have our hit particles for that, so we're going to pass in hit particles. Next, we have a F transform called spawn transform. Now, an F transform contains a location, rotation, and scale. But if I click the up arrow, I see that I have 3 different overloads of this function. They don't all have to take a transform. One of them takes a location, and the rest of the inputs have default values. So we can get away with not passing in the rest of them if our next argument is simply an F vector. So I'd like to use that one. And here in getHit, we have the impact point. That's perfect. That's where we want our blood to be spawned. So I'm going to pass impact point for that last argument and terminate that function call here with a semicolon, very important. And now we're spawning particles here in getHit. So let's test this out. I'm going to hit save so that my new changes are saved, and then kick off live coding with my new keyboard shortcut Control-Alt F11. Now that live coding is done, I'm going to close the live coding window and head back into the Unreal Engine editor. Now, I've broken this wire from begin play, so we're not going to hear that sound or spawn that emitter every 1 second like we were doing before. So I'm going to go ahead and press play and grab a weapon and run up to this enemy here and attack. And there's my blood particles, and it looks fabulous. And we can see that the blood particles are being spawned exactly at that impact point. So we get that level of realism based on where we hit the enemy. That's where we get our blood. And I missed. There we go, and I hit. So that's why these debug shapes are really nice for us to just make sure that we're spawning the particles at the correct location. We can now see that we are, and everything's working properly. And so for that reason, I think I'm just about finished with those debug shapes. So I'd like to see how this looks without those debug shapes, which means I can go ahead and remove them from my code. Now, one of those debug shapes is right here in get hit. We're drawing a sphere that's orange at the impact point. I'm going to go ahead and comment that out. I'll remove this later, but I'm going to keep it here, just comment it out for the commit for this lecture. So if you go back and take a look at the code in GitHub for this lecture, you'll see this here commented out, but I do eventually plan on removing this as I don't really need it anymore. Now, we're also drawing some debug shapes in our weapon class. If we go to weapon.cpp and search for where we're doing a box trace, I can search for box, trace, and searching through the file, I come to on box overlap, where we're performing our box trace single. And we're getting a debug box with our box trace because our eDraw debug trace is set to for duration. But I can change this to none, and now we won't get that box drawn every time we do a box trace. Now, that's not the only debug stuff we're doing here. We also have some arrows that we're drawing. And we're drawing those back in enemy.cpp in our directional hit react function. Let's go to that function. Here it is. We're doing some math. We have lots of comments explaining what we're doing, just in case you forget. But down at the bottom, we have our calls to draw debug arrow. We're adding an on-screen debug message for theta. All of this stuff is debug. So I can do a multi-line comment here. So I'm going to go ahead and make an extra line at the bottom, just beneath that draw debug arrow. And I'm going to highlight the closing multi-line comment symbol here, the asterisk slash, and simply click and drag it down to the bottom here. So I have this all commented out. And now we should no longer see those debug arrows. Let's go ahead and hit save all. And I'm going to Control Alt F11 to kick off live coding. And with live coding successfully completed, I can close that, head back into the editor, and press play, and grab a weapon to attack. So let's see how this looks. There's the blood, and we're not distracted by all those debug shapes. We're no longer drawing them, and this looks more like an actual game. Awesome. So this is really adding a lot to our combat. The sounds and the particle effects are really what make a game pop. It's great to know how to do things like gameplay logic and playing animations and making things happen, but those particle systems and sounds are really what's going to add a new dimension to your games. So it's really important to be able to add all those different effects and make the game pop in as many ways as you can. This is a great addition to our combat. We now have blood, and it's spawning right at the impact point, which is exactly what we want, so things are looking great. All right, excellent job. I'll see you in the next video.